Hello and welcome to our project. We are working on a continuous fiber Thermoset 3D printer. Composite fibers offer a high-strength, lightweight alternative to steel. Our sponsor, Aisman LLC, is looking into the possibility of 3D printing this as a way to make highly customizable parts to use for clients in need of orthopedics. This is a legacy project that other teams in the past have worked on to put together the physical body of the printer as you are seeing right now on your screen. Our main focus was to streamline this design and push forward on ideal parameters for printing. Here we have several components of the printers that were removed to better streamline it. The first being tubing, second being a mount, and the third being a stepper foot, all meant for the original cutting mechanism laser that you can see in the wrapping. Along with this, we also had a oven heating coil in the bottom of the printer that was meant to add as extra heating for any prints that went through. These components were not properly connected, caused overheating in the printer, and thus it was disconnected. Right now on your screen is a more optimized version of the printer after we removed all of these unnecessary components. Right now you can see a video of how printing went before any modifications were made. As you can see, the print starts off promising, but once it reaches any change in geometry, it begins to lose its shape and drag along the plate. The coding for the extruder was set at a singular invariable speed, meaning that the extruder was unable to keep up with the print and would thus drag it along. We adjusted this so that now the extrusion speed can be edited along with movement. We wanted to ensure that an accurate print was achieved no matter what. So we developed a theory. We created several print breads of varying surface areas to see if an increased surface area could ensure a better print. We created an apparatus to test the force required to break adhesion from the plates and attached it to the printer. Here we can see an example of how our tests were ran. Once that first slip occurred, we knew that the adhesion had been broken and recorded that value from our apparatus for further calculations. From our experiments, we found that our theory was indeed correct. Our highest surface area had an adhesion force more than double that of a regular plate. Once we found the ideal printing parameters, we then decided to move forward by making a full print sample. Then, once our coding path was done, we printed a sample. This was a huge success, especially since we were the first group in this whole legacy line of groups to achieve this, but we weren't done yet. From here, we sent the sample through a post-processing stage and we achieved a fully cured sample. With this, we were able to do even further testing. We wanted to determine the strength of this 3D printed part compared to that of other resin composite fiber created through previous means. To do so, we cut our print sample into a standardized sizing and had it undergo a tensile test in order to determine how much force it took to fracture it. In the end, we determined that our 3D printed part only had around 20% of the typical strength of other composite fiber parts. This is still a huge achievement. Even though further research still needs to be done into strengthening the parts, this already is a huge step forward in helping clients get their highly customizable braces they need.